So thank you for waiting, and thank you for joining the webinar. This is Designing Engaging Physics Courses Using Videos. My name is Dinga Jangisi, and I am the Curriculum Specialist for the Sub-Saharan Africa region. And with me is Lakshmi Srisam, who's the JoVE subject matter expert. And also with us is Priti, who's also a subject matter expert. So about JoVE, JoVE is the world's leading producer and provider of science videos with the mission to improve scientific research and education. So JoVE holds over 18,000 videos on science experiments and concepts with over 1,200 subscribing institutions around the world and over 66 million unique visits per year. So when it comes to learning new information, reading and visualizing offer different pros. Reading enables a detailed understanding of theoretical aspects and written protocols, while visualizing provides a concrete step-by-step visual representation, making it easier to grasp into intricate details and nuances. So visualizing becomes better to conceptualize complex procedures without the potential misinterpretations that reading only may bring. So combining these two approaches can lead to a more comprehensive and effective learning experience, as the combination of the text on the left provides with the video on the right. Thank you. So what challenges does JoVE address? So with JoVE, you're able to combat the lack of student engagement, students not comprehending complex concepts, and low student retention in STEM majors, and also students having poor test scores, and the time it takes you as the professor to create course material. Visualizing science to improve students' learning outcomes. So JoVE videos have huge impact. So these are the average results of students before watching JoVE videos and after watching our videos in an independent study at UCLA. And as you can see, that students firstly had an average of 28.9 before watching JoVE videos, and those results increased up to a great 89.5% after watching our videos. So we have seen better performance in lab assessments too. 100% better results in pre-lab and 76% on post-lab assessments compared to students who only read the lab handouts. Now, for the scope of the content, I'll hand over to Lakshmi to go into more detail on the content.
Hello, everyone. I'll first share my screen. I am Lakshmi Sriyasam. I'm a subject matter expert with JoVE. And today I'm going to discuss with you and present our physics videos, the videos that are there in our collection that are specifically targeting physics teaching. So before I go and delve into the details, I would want to share this excerpt from this very beautiful book called A Sphere of Physics by Lawrence Krauss. So this is a very funny and witty book written by theoretical physicists on how people how to deal with how to explain people physics basically. So here a physicist, an engineer, and a psychologist are called in as a consultants for a dairy farm where the production is below par. Each of them take their time, do their due diligence studies, and come up with a report. The first to come was the engineer. So what did the engineer say? He said that the efficiency can be improved if you reduce the size of if you pack the cows closely, thereby reducing the size, and also increase the size of the milking tube, thereby increasing the speed of milking, and all technical details. Then came the psychologist. He said that paint the walls green so that the cows are in a better mental condition and they don't go into depression. Plant more greenery so that they have the variety. Okay. And then the physicists come. He asks for a blackboard and draws a circle and says, assume the cow is a spear. So this is a very old joke. It is funny, but there is very one important thing that we need to understand, that how physics is taught is different from how other subjects are taught. There is a level of abstractness in most of the concepts that are taught, and this abstractness makes it a bit non-relatable to the students and thus inculcates a fear in them. Like people cannot relate, the students cannot relate it directly, and that makes it more difficult for them to understand. And today, as Singha has already told, visualization is going to help them deal with this fear. So today I'm going to show you give you an overview of our physics collection and how it is going to help you to make your physics teaching more engaging. So before I go into the details about the physics collection, just a very brief overview of our JoVE site. We have the our JoVE has research and education collections. The research collection is a peer-reviewed methods journal. There are video journals with a video of the protocol along with the journal article, and it's available in 13 different subjects. And along with that, we have encyclopedia of experiments, which is a curated set of experiments. Right now, it is available only in biology, but it is expanding. And in the education section has videos that are basically meant for teaching and training tool, focusing on the key concepts for the students. And there are three types of videos here. The first one is the core videos, which are shorter in length and are concept videos. The second is science education, which are the duration is slightly longer, and it's a mix of a concept as well as a experiment that is directly related to that. And the lab manual is a visual demonstration of laboratory experiments for the students. So let me just highlight you the key features of our core physics collection. There are 33 chapters with 498 videos, a little short of 500 videos. And it is available in 14 different languages as subtitles and closed captions. Each video is 90 seconds in length. And we have made it intentionally short and followed this principle that one concept for one video. So that makes it easy for the student to assimilate the concept, because the student won't get overwhelmed, and he'll be able to take small bit-size information, and that will enhance the comprehension and retention. And along with that, we also have 99 scientists in action videos. So what are the scientists in action videos? These as soon as as and when one particular concept is discussed in the videos, we have the research articles where these concepts are directly applied. So this will give a real world outlook and real world experience of those concepts to the students. Then we have conceptual animations that makes the abstract physics concepts more relatable to the students, and so that they can comprehend it better and retain it better. And they are all made using widely referenced standard textbooks. And along with that, we have clear explanations, and all our videos are visually stimulating. They are made to meet the global curriculum requirements, and they meet the learning objectives of most of the course. And they are fit the best for most of the undergraduate physics and engineering physics courses. So let me come to some unique feature of this collection. There are two, that is the problem-solving videos and real-world applications. These are present in all the chapters that we are discussed in our core physics collection. In the problem-solving collection videos, these have, like, whatever concept is described, there will be a problem that is related to that particular concept, and how to solve that is given. And so that this will actually help the students to understand the concept better, and also helping them in these various competitive exams where such questions appear. Here, there is one example where the tuning of guitar, the physics behind the tuning of guitar is beautifully explained. And then in the real world applications, where physics in everyday life, like how physics concepts are used in our everyday life. Like we have here, I have given an example of gyroscope, like how gyroscopes are used in a plane. And also we have videos like how a microwave oven, how the physics behind a microwave oven, physics behind an induction stove. All this, like, when these are all real world things that we do every day, and we have videos that explains the physics behind them. So this makes the students, the students to be more relatable, physics more relatable to them. Now I'll go to the contents that are actually present in our collection. For ease of understanding, I have put it into 5 different sections. The first is the foundation of physics, where chapters 1 and 2 discuss. And here, the foundational concepts of physics are discussed, especially the measurements, vectors, scalars, dimensions, and units are all discussed. This gives a basics for the students to be able to understand the upcoming concepts, more complex concepts here. Then we have a big collection, expansive collection in mechanics. Like there are chapters 3 to 13, where various aspects of classical mechanics, kinematics, energy, momentum, equilibrium, fluid mechanics, and are discussed here. The uniqueness here is that we have all the concepts. For all the concepts, we have problem solving and real world applications, so that the students can easily understand these various lessons that are discussed here. Then we have chapters 15 to 17 discussing on oscillations and wave, where the lessons discuss about all various different types of oscillations, simple harmonic waves, motion waves, the sound waves, the properties, and the various equations, wave equations are all beautifully described here. Then we have chapters 18 to 21 discussing about thermodynamics. Here we have given the basics of all the basics of thermodynamics are covered, so that the students can brace themselves for the advanced thermodynamic courses in future, which they come across in future. We discuss about temperature, heat, the kinetic theory of gases, all the laws of thermodynamics, the applications of these laws of thermodynamics. These are all described here in this section. Then we have electricity and magnetism. The chapters 22 to 31, they discuss the electricity and magnetism. Here we discuss about the properties of electric charges, electric fields, electric potential, magnetism, magnetic forces in magnetic induction, the DC, the direct current and alternate current and circuits, all are discussed in great detail here in this chapters. And we have slowly increased the level of complexity. We started it simple, and slowly the level of complexity is increased, so that the students don't get overwhelmed when they read these particular topics. So along with this, We also have the science education physics. As I told earlier, science education videos are longer in length, and there is a mixture of a theoretical concept and a practical of the same. We have 30 videos here in classical mechanics, thermodynamics, electrostatics, magnetism, optics, and electrical circuits. And these videos will be a very good, they not only give a good concept of the good understanding of the concept, but also they can be used for your practical syllabi or practical lessons also. So for those who are looking for an engineering perspective for physics, we have the science education engineering, where application of physics in various engineering subjects like electrical engineering and mechanical engineering is dealt with. And we also have a core mechanical engineering collection, which has 11 chapters on fundamental physics, principles, statics, vectors, equilibrium, friction, center of gravity. They're all given from with a mechanical engineering perspective. So these are all about, this is all about the various collections that we have about in discussing the physics with us. So now, how is the best method? What would be the best method to use this? That would be, right now we have what is called as a faculty resource center in our website. So this here we have comprehensive video playlists like on mechanics, electrical mechanism, waves and optics. So these are like a playlist of various videos that have comprehensive topics in each of this particular subject. So and all these playlists can be directly downloaded and can be downloaded and be used in your LMS, which Singa will tell you how to use that later. And along with that, we also have textbook mapping with us. We have mapped around around 11 textbooks in physics, all standard textbooks. And these is like, we have taken the textbook, we have looked into the chapters, the subtopics, the contents in this, and mapped our videos accordingly in the same manner as it appears in the textbook. So this would be like it would be like a excellent supplement for the students who are referring this textbook. So I will briefly stop my presentation and take you to a tour to our website to show this collection. So go to JoVE, and in JoVE, as I told, we have research. This is the research, and in education, you need to go to the physics section. And in the physics, we have here core physics and science education physics. So if you click on core physics, we have all the videos, all these chapters, as I mentioned. We have 33 chapters here, and any one of them we click, we have the video lessons under them. And each video lesson, if I just randomly take one video lesson, so each video, there will be the video will be there, and there is transcript available. It's available in the languages that are highlighted here, and along with that, there are it is also available in subtitles are available in the closed caption. And you have the transcript and some extra information, that extra useful information related to that particular lesson is also given here. So, and going back to science education, as I told, we have science education in two parts, physics 1 and physics 2. And each of this slightly longer videos, they have clear timestamps here. So you have the overview, the principles, and also the procedure for the experiment. So this would be a very good, very useful for practicals, physics practicals. And next we go to the faculty resource center that I was telling earlier. So here we have these are all the videos mapped to various courses. And here if you go to the physics, we have this in this, and any one of them, it's comprehensive playlist of all the topics that are present in that particular subject. And we have the textbook mapping in physics. If we go to physics, we have all these textbooks that are mapped here. Any one of them, let us just click on any one of them. So that here, as you can see, it's just like a video textbook. All the chapters that are there, click on any of the chapter. You have them in the same way as it appears in the textbook. So at this point, I would like to stop sharing. And before I give to Singer, coming back to the cow story that I shared in the beginning of my presentation. So our videos would help the students understand physics better, making them more relatable to them, making them more comprehensible so that they can retain it easily and they can apply it easily and maybe love physics and enjoy reading the physics. So over to you, Singha.
Thank you very much, Lakshmi. So now we will move over to how do you share this material with your students. I'll share my screen again. Okay, so firstly, you'd need to sign in to your JoVE account. Okay, so how do we do this? So we create a JoVE account. So if you go to app.jove.com, which will be put into the chat box, you'll find a screen like this, and you'll click on sign in, which you will see on the top right. It will bring you to this page where you will create an account. You'll click on create an account. You'll enter your institutional email address, and it'll give you access that your university holds. And then you'll get a verification email in your university institutional inbox. If you click on that to confirm your email address, it'll bring you to this page where you will fill out your information, and you'll select your role as a professor instructor. And then you click on create an account. And after that short and simple process, you would have created your JoVE account. Now I will be showing you how you embed JoVE playlists and videos into Moodle and also my class. And we also do embed into Canvas, Blackboard, Blackboard Ultra, and many other LMSs. So I will be showing you a live demo of how to embed on Moodle. So we go to JoVE. So at this point, you would have shared with me your course outline, and myself and Lakshmi would have created your playlist for you. After your playlist is ready, I would share it with you, and this is where you'll find it. So you'd go into your JoVE account where you'll be seeing your name over there. You click over there and you come to my playlists. And once you go to my playlist, you'll see the physics playlist that has been shared with you. And then we download CC. Right, now once that common cartridge has been downloaded, you would then have to go onto your Moodle account. Once you're into Moodle, you go onto the course that you want to add your JoVE videos in, and you scroll to where you want your videos to be. Once you've found that and you've made sure that editing is turned on, you come here where it says add an activity or resource, you click on there. you come to IMS content package, you click on there. And then we name the course. For the sake of this exercise, I'll say Physics 1. And then you can add a description as well. Where it says content, you come to choose file. And we click on there. And then we say choose the file. Now, it is the file that we had downloaded, which was Physics 1. We select that and we click on open. And we say upload file. Once we've done that, you can click on save and display. And you will see the video over there with the notes underneath. And that is how you would embed a video using Moodle. Now, I will also show you how to embed videos using my class. So you would have to go onto your JoVE account, access your JoVE account, and then click on the education drop down and then select my class, which will be all the way at the bottom. Once you have clicked on that, you'll click on create new class. And then an overlay window will open, and then you'll enter your class details, filling out your necessary data, and then click on new class button, which we will see at the bottom over there. And once you've done that, you'll click on add playlist. An overlay window will open and you'll insert the playlist present in your account, which is the same playlist that I would have shared with you. And then it is also possible to add more than one playlist at a time. And then you click to confirm the playlist to add it. And then we come to how do your students get access to these videos? And then there are 3 ways. You can have a class code, which will be provided once you click on invite students over there in the top right. Or you can share a link, which you'll also get in the My Class part of the website. And then you can also add your students or invite them by sharing the students' email addresses. So, and then how do students join a class? So students need to log on to their JoVE account and click on join class, join the class button, which will appear over there in orange, and that only appears in a student profile. And then on the next screen, the student can enter the codes that you provided to them. And once they've confirmed the code by clicking on proceed, you'll be able to access the class and watch the videos and answer quizzes that you've added. And that is it. So at this point, you may request a curated playlist from us, or you can book a demo, one-on-one demo with me, where I can show you how you can get your playlist created for you, or how to embed the playlist into your LMS, and also integrate your resources into your LMS as well. So thank you very much. You will then find my email address in the chat box, and also you'll get more information with the video once we send it to you. And that is it. Does anyone have any questions for us? If you have questions, feel free to add them in the chat box for us. Okay. So, right. So, Dixon, You can share videos in Google Classroom. And then once you book your session with me, I can be able to show you how to embed those classes in your Google Classroom. Thank you very much, Prerna. Prerna has also added a file on how you can do that. Okay, subscriptions are university or library based. So the subscription will come from your library. And if you want more information on that, KU, who is the account manager for the region, will provide more information. Hello, Ian. So at the moment, we do not have access for you to download the videos on offline and use them offline. They can only be used via your LMS or through my class, as you've seen here. And can one create his own playlist? Yes, you may. You can go onto the website and select videos that you like and add them into a customized playlist. Thank you very much, Prerna. And Prerna has also added a file on how you can do that. Do we have any more questions? Get in touch with my university, Technical University of Mombasa. All right, thank you very much. Okay, demonstrate one live video at the university, and we already are. She can make videos and tailor them the way that we want. We're able to edit or modify the videos to fit the course content. The videos are not editable to fit your course content. The video comes as it is. That is to Jeffrey. And Lakshmi, if you may also share a video that they can see.
Any particular topic that you want me to mechanics or I'll randomly open one for you? Yeah. So just this. So sorry, once again. So these videos, you have closed caption and also the speed can be modified. So I'll put it in the normal speed.
Okay. Actually, I think we have a problem with the sound.
Okay.
So if you can stop sharing, and then I will share and see if I can play the video with sound.
I'm sorry, I think there is some issue with my my audio in my laptop. Singa, you can open and show it from yours.
Okay. I'll just play a random video. As you can see, there is the video over here. That will populate over there. And you have the video notes underneath it.
When an electric field is applied across a conductor, free electrons drift in the direction opposite to the field's direction, while colliding with the crystal's ions. If the applied field were zero, the random motion would, on average, result in zero net drift, as the collisions would randomly change their directions. The average time between collisions is called the mean free time. The electron's acceleration is given by the electric force over the mass. Its velocity at any time is expressed by the initial velocity, the acceleration, and the time. Averaging both sides over the collisions gives the average velocity. However, since the average drift due to collisions is zero, the drift velocity is given by the product of acceleration and the mean free time. Using the relationship between the current density and the drift velocity, the current density is related to the electric field, which is Ohm's law. So, the electrical conductivity is expressed by the number of free electrons per unit volume, the electron's charge and mass, and the mean free time.
All right, that is the video. Hope you have enjoyed that one. Do you have any new questions? Yes. So if you have requested a video, okay, KU has answered. Okay, no new questions have come in. Thank you very much to everyone that has joined the webinar. And thank you for leaving your questions. And we hope that everyone's questions was attended to and answered to your satisfaction.
Singa, 1 second, there's one more question. Like on, I would like to answer that. Do the videos undergo peer reviews? Who are the current reviewers? So the research videos that we have, it's peer reviewed like any other journal. But if coming to the education videos that we have shared, it is made by the production team, which has a group of experts in that particular, like PhDs and experts in that particular subject, and it is rigorously reviewed internally, and also so there, and it is made according to a textbook, like they're very widely referenced textbook is used. So, and it undergoes internally, a lot of reviewing is done before. There's a lot of quality controls that we have, and then only it comes to you. Hope that answers your question. Again, this question I'd like to answer, Kenneth. So please share your requirements with Singa. So we will take a look at the what are the requirements, and we will suggest you the best suitable videos for that.
And if there are more people that would like an institutional session or departmental session, do feel free to reach out to myself or to KU, and we will organize that. All right, then thank you very much to everyone who has joined again, and have a wonderful day further. Have a good day. Bye-bye.